Hello again, third graders. This week's topic is multiplication using the traditional algorithm. The traditional algorithm has been used for years upon years. This is the strategy that your mom and dad and your grandma and grandpa were taught. They weren't taught the other strategies, so this should be familiar for them. The traditional algorithm for multiplication looks very, very similar to the partial product strategy that we've been taught before. To do traditional algorithm, we would start off by looking at the ones place, and if we have 17 times 4, we would start off doing 7 times 4. 7 times 4 equals 28. I'm going to put my 28, and then on the side, I'm going to show that I did 7 times 4. I multiplied the ones digits in both of my factors. Then I would circle the other part of my traditional algorithm, 10 times 4. This is where third graders make a lot of mistakes, is they treat that 1 as a 1 and not a 10. The 1 is in the tens place, so it's actually 10 times 4. And if we do 10 times 4, that would give us a total of 40. We add together, and we will get a total amount of 68. Let's try this example. We have 33 times 3. You'll see at the top right, I've shown an area model of 33 times 3, 3 groups of 33. Using the traditional algorithm, we'll start off by multiplying our ones digits. 3 times 3 would give us a total of 9. And I'm going to show on the right hand side each step of our multiplication strategy. Then I would do 30 times 3. Again, this is not a 3. We need to treat it as 3 tens, or 30. And 30 times 3 would give us a total of 90. If we add those together, we get our answer of 99. Now let me show you what was going on with the area model. Our first step was to do 3 times 3. If you look at the top right, that's our area model of our ones. 3 groups of 3 would give us 9. Then our second step in the traditional algorithm is to multiply our tens digit, and that would be 3 groups of 30, and that gave us 90. And we put those together to get a total product of 99. Before spring break, we were taking a look at counting coins. One of the coins we looked at was a quarter, which is equal to 25 cents. Let's do this example. If we had 8 quarters, that would be 25 times 8, and if we wanted to find the total amount, we could use the traditional algorithm. We would start off by multiplying our ones. 5 times 8 would give us a total of 40. And again, on the right hand side, I'm showing each step as I go along. Then I would multiply 20 times 8. And 20 times 8 would give me a total of 160. I add those together, and I would have 200 cents. 200 cents, or I could say that it's equal to $2. Now it's your turn. Try this example. 26 times 6. If we have 26 students and each student is going to receive 6 stickers, how many total stickers would we need to have? Try it out. Pause this video, and when you have your answer, go ahead and play it and check your answer. Alright, so we would do 6 times 6 to begin. That would give us a total of 36. And then we would do 20 times 6. That would give us a total of 120. And if we have 36 and then we add 120, we would get a total product of 156. 156 would be our answer. Now the traditional algorithm strategy, just like any other strategy that you've been learning in third grade, will work for any multiplication problem. But in third grade, we only go up to 2-digit by 1-digit multiplication. So let's try this one. 99 times 9. 9 groups of 99. See what you get for your answer. Try it out. Pause the video and then double check your work. Alright, using the traditional algorithm, we would start off by doing 9 times 9. And 9 times 9 would give us 81. And then we would do 90 times 9, and that would give us 810. If we add those together, we would get 891. 891 would be the correct solution. You've done a great job today learning about the traditional algorithm to solve multiplication problems. Hope you learned a lot and had a lot of fun, and we'll see you soon. Bye-bye.